Hi guys, in this video I'm going to show you how to create an equivalent of the blueprint gate node in C++. Those who use blueprint a lot might be really familiar with that. When I learned Unreal and the C++ framework, I did that by converting a lot of blueprint scripting to C++. But one thing I was always hating a lot was when I saw those blueprint only flow control nodes like gate or do once and the like. So I started to create reusable structs and other components that I can use when converting these blueprint nodes to C++. And now I want to show you how to create that gate struct in C++ with a simple example I prepared. So let's get started. So in Unreal, let's first have a look at the small example that I prepared. It's just really simple. Let's hit play. So we have a label and a count, and once I hit execute, I can click and the count increases. If I close the gate, execute, nothing happens. If I open the gate, execute, I can continue clicking. Real simple example. Let's have a look at how this looks like. This is the widget, and I just, for each button, I created an event, have that gate over here. Once it enters the gate, I increase the count and set the text of the button or of the label. And the open and close button, they open and close the gate. So this is the famous gate in blueprints, and we are going to create a C++ reusable struct for that. So let's have a look. I copied the same widget. It's the same, only that the buttons don't have events and so on. There's nothing in here. And I created a C++ class of the widget. Let's have a look inside. So this is the test widget CPP, which has binding for the text block, the 3 buttons. I have 3 functions for the click events and a count value, which is private. And in the CPP file, I include all the necessary stuff. Then if the button, execute button, close button, and open button exist, I will add the function bindings to the onClicked event. On execute click, it increases the value and sets the text. And the onClose open click, and of course this is still missing because we need to create our gate and add it to this class. So as an example, let's change this. So what I did is, in this test map, I used the level blueprint, open level blueprint. It opens this one here. And in begin play, I just created a widget and added it to the viewport and open this up. So first I selected the test widget, the blueprint version, and now I'm changing it to the test widget CPP. So if we compile, save, and hit play, you can see I can click execute. This is the C++ functionality. If I hit close, nothing happens because we don't have a gate yet. And let's go into our IDE and create this file. What you usually could do is, here's our C++ files. You can right click, add a new C++ class, and there is no struct or anything for this. So if you've seen my other video about struct, you know how to do this. Add a object class and call it gate and so on, and create that class. It will compile, then you need to change it. I want to show you something. If you guys use Writer, we can do it a little differently. So let's head over to Writer, this IDE, and there's a neat functionality that I learned about, which is an easier way to create classes than through the Unreal editor. So for example, let's right click on here on our folder where all the files are in, right click, click add, and then it has an option Unreal class. If we open this, you can see it doesn't have all the classes, but if you're more familiar with the C++ framework and you know you just need an actor that inherits from this or that, or you need a character, an interface, a pawn, it offers the basic classes that you all need. Object actor. So you would go click actor, for example, if you're creating an actor, and then you can add all that stuff manually. Or you're really not that familiar, and then you can go through the Unreal Editor class creation, like I said, new class, and then you can click actor, scene component, whatever you need, or through all the classes that are available. And now for this, we are using an empty, give it a name, call it fgate, hit enter, it generates the file, and we have our gate h and gate cpp. We don't need the cpp file. So I had many people ask me, how do you delete this file in Visual Studio? I have to go outside in the Explorer, delete the file, restart things, and so on, because I didn't use Visual Studio, I used Writer, and here you can just right click, edit, delete the file, and it's gone. And it updates automatically the Visual Studio file and everything works. So let's have a look at our gate, make this a bit bigger, and of course we need to change a few things. So let's start by creating this gate class. Next. So I'm going to type this line by line so that you can follow along easily. So we don't need the core minimal. So for example, each file needs the generated.h variant included. So we need a gate.generated.h. In case you're not familiar with it, this file is really what the Unreal header tool, once you run compile, generates. So, and this needs to be the last include in this file. And like all these macros, they get really generated into code, and this is actually that file that then will be used. Actually, what we are always coding is like a template which gets compiled into that generated file. But that as a side note. So what we need, as said, we need to create a struct fgate. We need to make this a ustruct and blueprint of blueprint type, so that you can also create these structs inside of blueprints if you want as a variable, for example. Then what we need is the generated body, the general stuff that all classes and struct need. And then let's create or rather two constructors. We don't need the destructor. We say force inline, do it like this, and then we create another variable, because let's have a look at this for now. Let's go to our test widget and see, okay, our gate, it has an option start closed, and we can tick it so it's closed from the start and we need to open it before we can use it, or it's false and then the gate is opened from the beginning, and we have the enter, open, close, and toggle functionality. So let's go back. And to be able to use that functionality to say, when we create the gate, open it or close it at start, we need another constructor that has a Boolean as a parameter. So what we do is say explicit. I will shortly explain again, if you don't know what it is, what explicit means here. Force inline and create the gate and have a bool as a parameter, be start closed. And what we can do is now define our private property that we need for it. It's the most important thing. It's a UProperty that defines, is the gate open or closed. So the struct is nothing else than like a reusable Boolean that has functions that you can call, so to make your life easier when using this gate struct in your code. So we have a bool b gate open, and what we can do now is implement the constructors. So You can do this also in a CPP file, but it's because we're doing this force inline, it's more efficient. We do everything here in our header file, gate, and the way you specify default parameters is with colon and then the variable that you want to set, bgate open, and we give it a default value of false. And then you have these parentheses. And then for the other constructor, let's copy this, but instead we say bool or const bool b start closed, and we now set our bgate open variable and do it like this. Because we are doing it the way like the blueprint gate node does, we are kind of like inverting our variable, because our variable is mentioned open, and this bool value means when you say true, then it starts closed. And so we are actually inverting the start, that value that is passed, to set it here. So these are the constructors. This is our variable. And now what we need are 4 functions that kind of like do all the functionality the gate node does. So we do a force inline. So the first function will be open, and bgate open equals true. You copy this. We have a close function which tells bgate open is false. We have a toggle function which toggles between, if it's true and you call toggle, then it's false, and vice versa. So similar to what we did here, we then invert the value itself. So if it's true, then it's false. If it's false, then it's true. And then the most important function of all is what we will use with this is a function called isOpen, and it will return the bgate open variable. So this is actually our gate. Let's compile this, see if this works. Of course, it didn't. It said gate generated does not exist because I made a mistake. Let's rename this to gate.h and not fgate. And now you can see gate.generated exists. The class is called fgate, or the struct is called fgate, but the header file is only called gate. Now compile again. It compiled perfectly. So let's go to our test widget CPP file and see how we can do this. So let's define a UProperty of visible anywhere. For example, call it fgate gate. You can see we need to include this, so Alt Enter. So we include the gate.h file in here and define our gate property. So how do we use this? So I mentioned that I explained what the explicit means over here. If we use explicit, the only way we could define or call the constructor with the false value as only like this. So we need to call the constructor itself and type in false or true if it should start closed. So doing false, this is how you would need to declare your constructor. If we get rid of the explicit, for example, then we can implicitly call that constructor by just, instead of, let me cut this out, just saying false. And this would work. But this is so unreadable. It's really, why can I assign false to a struct? It makes no sense for when other people read this. So it really is important to say explicit. It makes the code much more readable. And you can see now, because it's explicit, false does not work. So we really need to call the specific constructor. But what we can do here is we just create the default one, and it will be closed from the beginning, and we make it easy and readable if we go into our CPP file, and on native construct we just say gate.open, so our gate will be opened. And then in here, what we can say on close, we just say gate.close, and the open button calls the open function. And now what do we do with here? Like when you look at it, if it's closed, this exit functionality is not called. So we just need to check, is it open or closed? And this is why I mentioned this is the most important functionality for this, the open function, because we just say if gate is open, then we execute this functionality. So this is what you would do to see, or if you use the gate functionality, what comes after the exit pin in here. We just need to check if is open for that. So let's compile this and then test it out. So it compiled. Let's head over to Unreal and close this one. So we have our widget assigned. It's the CPP widget. Let's head over here, test it, hit play. It should be open from the beginning. If we hit close and execute, the number of clicks doesn't increase. If we open it, click execute, then it works again. So we've recreated the basic gate functionality in C++. So when you are faced with converting your blueprints to C++ and you use gate in there, you now have the possibility or to use this class and convert it easier for your purposes. And in the next episodes, we will have a look at the do once node and convert that to a reusable struct similar to the gate. So that's it for this video. If you have any questions, please feel free to leave them in the comments. I try to explain everything to the best of my ability, but if I didn't or things were unclear, feel free to ask and I will gladly answer any questions you might have. So I hope you enjoyed this video, and please leave a like and sub if you did. Thanks for watching and see you in the next one.